Welcome to this video in which we solve the Excel Lab 1. You need the Excel Lab 0.pdf in which you have the instructions. You need the Excel file in which you have the given data and the cells highlighted in which you have to enter the formulas highlighted and ready to enter your formulas and answer key in it. And the Excel has two different sheets, one for the students' grades and one for the multiplication table. You also may need to refer to the slides actually, which are given in this PDF file Excel lecture 1.pdf, so that you can check the formula explanation. Let's start with the first step, which consists on opening the file lab0.excel. So it's already done. We can rename it as lab0 solution so that we can keep on the original file intact. Step number 2 consists on filling in the IDs of the students from cell number A3 here to cell number A11. To do so, we have to enter at least two different values so that Excel can detect the reason of my arithmetic series. So I can select these two different values. I can drag down this magical square, tiny square that appears to the right of the cell, and then apply it down up until the last cell. You may notice that if I drag only one cell, the first one, up to the end, I will copy its value to the other cells. However, if I select these two different cells by clicking on in the middle of the first one and then dragging my mouse up until the second, then by clicking on the magical square, in this case Excel will detect my arithmetic series and then it will create it correctly. You may notice that the IDs here are considered as decimal numbers with two digits after the radix. To get rid of these digits, I can use these buttons actually to decrease the number of decimals. Otherwise, I can also click on this button here to get the full formatting options of my cells, and then I pick up here number, and then I can decrease the number of decimals using these two different controls. You may notice that there are plenty of other options, including percentages, currency, and so on and so forth. I will validate with OK, and then I'm happy with my column. Next step is actually to fill in the cells from G3 up to G11 with the formula that allows to calculate the sum of the math, physics, and philosophy grades. They advise us actually to do this first using the plus sign arithmetic operator. Predefined sum formula. So let's do it using the plus operator. So to enter a formula in Excel, we need the equal sign. We start with the equal sign at the beginning, and then we can start selecting our parameters, adding our operators using the keyboard, and then we can type also the name of a certain cell manually by typing E3. Excel automatically highlights the cell, and then I can add the plus sign from the keyboard and then select the last one. So you can use whatever manner you see it fit. I hit enter to validate my formula, and now I have the sum of these three different values. I can apply my formula up until the last cell in the column, and I will get the expected result. Another way of doing this formula is using the predefined function that is called SUMIF. To do so, I'm gonna create a new column. By the way, to create this new column, I clicked on the column name, right-clicked on it, I hit insert, and then I'm gonna use some function here. If the column is not large enough, I can adjust it from this side here. And now I'm gonna hit the sign, the equal sign, use SUM, and I can either now hit the tab button key from the keyboard, okay, to validate my choice. Otherwise, I could also double click on the function name to validate my choice. So if you have the mouse in your hand, you can double click on it. Otherwise, if you're simply using the keyboard, you can hit the tab button, and then the function will be chosen, and the guide of Excel will show you the various parameters that you should enter. To give the parameters to the sum function, I can give them by selecting each parameter, adding a comma, and then selecting the other one, adding a comma, and selecting the third one. This looks very similar to what we did with the plus operator. And this is tedious. If I have, let's say, 20 different values to sum up, it will be a complex and tedious task. Actually, Excel allows us to do to select the range of cells, subsequent range of cells with a easier way. So I can select the first cell and then drag my mouse cursor until the last one. This will give a different parameter, which is D3 colon F3, and it means from D3 to F3. It is considered as one single parameter for the sum function, yeah, but the sum function will automatically calculate the sum of all the values that exist within this range. I can close my parenthesis and then validate with enter. And now I'm happy with my function. I can apply it up until the end. As for the average, I can also calculate the average into different manner. I can say that it is the sum of this value plus that value plus that one divided by 3. But notice that if I validate my formula now, I will have a very big number because I'm just dividing F3 by 3, but I'm summing up with it then E3 and D3 grades. So to obtain the correct average, I should parenthesize my first part of the fraction. Like this is one way of doing things, of course, and it works very correctly because I'm using the plus parenthesis and division operator. But I can also calculate the average using a function as I did with the sum. And here we simply type average tab to select the average function, and then I can select these values here and then validate my function. Automatically, the average function will sum up these values and divide it by their number. However, on these lines, since I do not have any grade, actually Excel is dividing by 0, and it is displaying an error that there is a division by 0. In the next video, you will see how we can decorate this value here actually and prevent Excel from displaying an error if there are any, okay? But for the moment, let's be happy with this. You can simply remove the function or you can use this one just in case, okay? Notice that while calculating the values here, Excel is automatically making a certain line translation or a transition on each line to consider different values. So the formula that I entered on the first line is the average of T3 up until F3. When I drag down my formula, Excel automatically considered calculating the average of D4 up until F4. And this is great since this is the cell named G4 and which is in front of these values. It's perfect that I can have their average and not the average of the first line. The same is happening here. So Excel has this tendency actually and default behavior that is to make a transition of the line number of the parameters when applying the formulas up or down within the same column. And if we apply the same formula to the right or to the left, it will make an automatic column transition. So let's try, for example, to calculate the highest grade here on this line. So I'm going to use equal, and there is a function called max. This time I do not have an operator to do it. I can only use this function. And then I'm going to select this range of cells. By the way, I'm keeping on these cells blank because I'm imagining that during the semester, maybe I will have other students who will show up and will register in my class, and then I will have grades for them, and so on and so forth. So this is why I'm taking into consideration in my formulas all the cells, and just in case someone will show up, let's say Fadil, who registered recently, will do the math exam and will get 20, then the max will change automatically. Besides that, all the grades of the sum, average, and so on of Fadil have changed automatically, if you may notice. So if I have 20, it will automatically be displayed on the screen. So beside it, actually, you notice that the values that I'm considering are D3 to D11. Once I apply my formula to the right, then the max actually will be calculated on the corresponding columns. So you notice that in my formula, Excel already made a transition of the column name. So in this column here, in this cell here, it's considering calculating the max of E3 up until E11 instead of D3 up until D11. So sometimes we don't want Excel to make this transition, and this is what we will be doing in the weighted average calculation in a few seconds. So what is the weighted average? A weighted average, it's actually an average, but that is actually calculated with respect to certain weights or coefficients. So what is the basic formula for this? So to do it, we can use basic operators. Actually, we're gonna make this custom function that will take the value of the math grade, will multiply it. So we're gonna pick the star operator to multiply the math grade by the weight of the math grade. We're gonna use the plus sign to multiply the physics grade by its coefficient, and then the plus sign once again to multiply, sum it up with the multiplication of the philosophy grade times the philosophy coefficient. And then to get the average, we have to do this summation, and then at the end, we have to divide by the summation of these coefficients. So I'm going to pick up D1. We can use also the sum function, actually, and then I can select D1 up until F1. So this will select this whole range from D1 up until F1. This will make the sum of the three coefficients. So usually this formula gives us the exact weighted average. Everything is fine, it's correct. Nevertheless, if I apply my formula down a few bits down, I will notice that I have erroneous values, especially on this line. So if I double click on this line to check what's happening, I will notice that Excel made an automatic transition of the line numbers of the parameters D3, E3, F3 to consider the values of the next line, the grades of the next student, which are at D4, E4, and F4. Nevertheless, it multiplied by D2, E2, and F2 instead of considering D1, E1, and F1, which are fixed cells and contain the coefficients or weights. So to prevent Excel from doing this transition, I need to fix the line number in the original formula. So I'll get back to my first cell here, to my first formula. I will add a dollar sign before the line number in these parameters to say that I want to always consider D from line 1 and E from line 1 and F from line 1, and I want to divide it by the summation of the values from D line 1 to F line 1, and never change this in the subsequent cells. However, I will keep on F3, E3, and D3 free without any locking, without dollar sign, so that they can be transitioned and translated automatically onto the subsequent lines. Let's try out this effect, the effect of this dollar sign. So if I apply my formula down now, I will notice that on the second line, I will multiply these grades but with the same coefficients, and then I will divide by the sum of the same coefficients. If I check the values here, I will see that they are multiplied by these same coefficients, and so on and so forth. So this is the crucial and very important effect of the dollar sign in the formulas. Let's now switch to the if-else statement in Excel, in which we can display different values based on the evaluation of a certain condition. You can refer to the slides to check the exact syntax of the if condition formula. So let's do it together. So the if function takes a logical task and evaluate it. If it returns a true, then we display the value that is given as the second parameter to the if function. Otherwise, we display the third value. Okay, sorry, the second value. So we can use it actually, for example, here to display whether the students have passed the course or the semester or not. So we use the equal sign. We start writing if. When the function pops up, we can double click on it, and then the value to evaluate is the weighted average, because in the given of the lab, they say that depending on the weighted average, if it is greater than or equal to 10, then we display pass, otherwise we display fail. And in the step number 7, we should display either pass or nothing at all. So let's do this. So I'm gonna select this value here. I'm gonna check whether it's greater than or equal to 10. I have to write the equal sign after the greater than, because I do not have the same symbol as we have on paper. I'm gonna write 10. The value to display, if this is true, is the word pass. I should give it between double quotes, and otherwise I should display fail. I close the parenthesis and I validate my formula, and then I apply it down. If I'm only interested in knowing who passed the course, I can change my formula to display nothing if the condition is false. It means if the grade is less than 10. I can validate my formula once again. It won't change anything in the first cell, but actually on the other cells where I have a failing grade, I won't display anything. So as for the lateral grade, that is explained in step number 8, we have to display the lateral grade A, B, C, D, F based on the grade, the weighted average, and depending whether it's greater than or equal to 18 over 20, or whether it is between 16 and 18 over 20, and so on and so forth. So to do so, we need a nested if that is explained here in the slides. So simply, if the logical test is true, we display this value. Otherwise, we wait. We don't display anything. We delegate this to another if that will check another case. And if the other case is true, we display a certain value. Otherwise, we can either display a third value or simply delegate the test to a third if statement to be able to display a fourth different value, and so on and so forth. And here we have the example, exact example in the slides, except that we have to translate the values from the 100 scale to 20 scale. So let's do it in our case here. So we use equal sign. We start with an if. We double click on it. We select this value. If this is greater than or equal to, let's say, 18, we display the letter A. Otherwise, we should test once again. So I'm going to close the parenthesis to not forget to do it, and then I'm going to click on the third parameter and then type a new if. Within this if, I'm going to check once again whether this value is greater than or equal to 16, because I'm already in the else case it's not the case that is greater than or equal to 18, then it means it's strictly less than 18. It's sufficient to check whether it's greater than or equal to 16 to be able to display B, and otherwise, well, we have to check once again. Imagine that otherwise I'm going to display C, and just to check that I succeeded in making a nested if for at least one level, by applying my formula, I will notice that I will have either C's or B's. Let's increase the grade of someone. For instance, here, let's add this up to 20, and then this grade will switch automatically to A. Okay, so my formula is working very well, except so I'm succeeding in displaying 3 different values at least and using 2 nested if, but except that it's not the case that it's only C if the grade is not greater than or equal to 16. We have other cases to test. In this case, I'm going to use a third if, and I'm going to test once again, but this time whether this value is greater than or equal to 14. In this case, I can display C. Otherwise, I still have 2 different cases, D and F. So I cannot stop. I have to check once again, one last time actually, for the value whether it's greater than or equal to 20. So if it is the case, I'm going to display D, and otherwise I'm going to consider it as an F value. If I validate my formula, I drag it down. Now I have a very correct formula on all the lines. And once again, if I change one of the grades, let's say 20 here, and then 20 there, and then I will have A, B, C, D, E, F. Perfect. Now let's do the following questions. We need to calculate the number of students. To do so, we can count these cells, but actually it's not a great idea because we already prepared the IDs for the total capacity of the class. But what we are imagining here is that we are going to add new names for the upcoming students in this column. So maybe by counting the number of filled-in cells in this column, we can get an idea about the dynamic number of students that is increasing or decreasing. And to do so, we can use the count A function, because count, it only counts the number of cells that contain numbers. However, count A, it counts the number of cells that are not empty. And there is count blank that calculates the inverse. So we can use count A and we can select these cells here. Okay. It will display 6, but you notice that if I add Samuel here, so the number will change automatically. If I remove Samuel and then I remove Fadl, the number will decrease automatically. It's perfect. It's taking effect as expected. Now to calculate the number of SV students, I need another formula that takes in a criterion. It's called COUNTIF. You have to select the sequence of or the range of cells, and then you have to provide the criteria. The criteria here is a text, so I can enter it as exactly as it is written, as V, and then I validate my formula, and I find that it's giving the right answer. I can switch from SG to SV on one of the lines, and this will change the value automatically. Well, to calculate the number of students who fail in physics, it means whose grades on physics here are less than or strictly less than 10. I can also use COUNTIF. I have to select this column here, and I have to give the criteria between double quotes. Okay, so this is the only weird thing about COUNTIF is that you write down the criteria between double quotes as if it was a text. But believe it that Excel, it will evaluate this condition on the lines. So now if one of the grades switch, for example, like this one, switch from 20 to 10, the grade, the number won't change because 10 is also a passing grade. If the grade passed to 9.5, the number of failing students will change automatically. So what about the sum of grades of the students who passed math? To do so, we use the SUMIF function. We select the math grades and we give it the criteria. So SUMIF works as COUNTIF, but instead of just counting the cells, actually it sums up the values that exist in the cells. So now every single value that exists between D3 and D11 and that is greater than or equal to 10, it will be summed up. We will end up with these values. Maybe you are having this value here because I changed my file and I added 20 at the end. Let's do the sum of the grades on philosophy of the students who passed math. To do so, we should also use SUMIF. The range on which I want to apply my criteria is exactly the same, the range of the math grades. The criteria is also the same as the previous question. I should check whether the grade is greater than or equal to 10. However, I need the third additional parameter, that is sum range, and in which I have to select the range from which I want to sum up the grades. Actually, we want the sum of the grades on philosophy of the students who passed the math course. So the criteria is always applied on the math column as before, but now I have to select a different range, a parallel range to that one, in which I can find the values to be summed up. When I validate my formula, I will obtain the right result. Maybe you have this different result because I added 20 manually here in this column. And now to get the average on the weighted average of the students who passed physics, actually I need I can either solve it using SUMIF divided by COUNTIF, or I can use AVERAGEIF, and then I can select this weighted average column, and then select the criteria. I'm sorry, so the criteria is applied on the column of the physics grades. So I need to select the physics column, and then the criteria is greater than or equal to 10. And then the values to for which to calculate the average is the column K3 to K11. Okay, I validate and then I will get the average of the class. Now with the last function, which is the VLOOKUP. To understand the VLOOKUP, we need to get a look at it. Actually, it takes a value to search in a table, and once the value is found in the first column of the table, then you can pick up whatever corresponding information to display about it. The last parameter is optional, and we use it only if we are searching an exact match. So let's check this formula. Here we are expecting that we are going to enter dynamically a different student ID each time, but once we change the ID, we want to know the major of the corresponding student. So actually the value that we are searching exists here. So let's start by typing VLOOKUP. We pick up the function with a click of the mouse. The value to search is this one. This is where we are going to type the ID. The ID exists in this column, so we start selecting our table along with this column here. And then if we only want to know the major of that student, we can select up until this column here, but nothing prevents us from selecting additional columns if necessary, just in case we are going to change the information that we want to retrieve about the student. So, and then the column index is the number of the column. So column 1, column 2, column 3. So we can type 3 to return the major of the student. Okay. If we change the column index and we type 2, for example, then we will get the name of that student. If we change the ID, of course, and we type the ID 4, then the value here, it will be looked up, and a different value for the name or the major will be returned. Okay. So if I select 3 once again, then this will return exactly the right information. So what if we are searching by student name? You notice that my IDs are numbers and they are actually sorted from 1 to 9. However, it's not the case for the names. I have Ahmed, then Wadad, then Samir. it's not the right alphabetical order at all. Okay, so in this case, we will need the fourth parameter of the VLOOKUP function. So let me use VLOOKUP, double click on it, and then I'm gonna select this value here. This is the value that I'm gonna look up for, and the table should contain the value in its first column. So I cannot select from the ID column. I have to select from starting from the names column, and then I can extend my selection up until the last column containing the useful information, which is the major ones again for me. So and the column index is 2 this time because this is the second column, not the third column as before, and then in my table. And then if I validate, actually I will get most probably an erroneous value. Samir actually is an SG student, however I'm having SE for the name. So the reason is that Excel is looking in the alphabetical order. It's expecting that the values are sorted, and once after Ahmad it will find Wadal, it will assume that Samir does not exist in this list, and it will return the measure of Ahmad. You will say, why this is happening? So imagine, for example, I'm searching with the math grade, and I want to check for the first, and I'm sorting the, I have the values on the math grades already sorted, and I want to know what is the average of the first a succeeding student. In this case, I may have several different students with the grades that are greater than or equal to 10. Maybe I don't have exactly 10, but I have 11. In this case, since the values are sorted, Excel will search up until down until it will find a failing grade that is strictly less than 10. Imagine 9.5. It will go up one step to find that the first succeeding grade is 11, and it will look up, for example, the corresponding average, and it will tell me that or the name or the ID, and then it will tell me that the first succeeding student is called Hanan or Wiam or whatever, and his average or her average is this value or that value. So this is useful actually when we are searching with sorted columns of numbers. However, if you are searching with names, usually unless they are sorted, maybe you are interested in getting the exact match. Okay, if the name is misspelled, then we need to get the exact value. And to do so, we have to type the fourth parameter of the VLOOKUP, and the fourth parameter is by default true to get an approximate match, as I told you. However, if you select false, this will get you an exact match, and this will work very fine for the names even if they are not sorted. For example, Samir is really an SU student. As for the multiplication table, here we need to multiply this value by that value. However, if you try to apply your formula down or to the right, you will obtain erroneous values because Excel is making a column and a row translation. You can check up different possible solutions. However, what you will end up doing is to fix the row number in the parameter C3 to always consider D3, E3, and so on without translating the row number when applying the formula down. So I'm going to add the $sign before the row number. And for the column B4, we should stick to it even if you are applying our formula to the right. And we should prevent Excel from making a column transition. And we can do this by blocking the column name in the parameter B4. We should not block the row number because we need to consider B5, B7, B8, and so on while dragging our formula down. So you can check up different possibilities. You will end up with this one, exactly this one. And then you will notice that if I apply my formula down one step, and then if I apply my formula to the right one step, the whole table will be filled in correctly just because we entered the right formula at the beginning. Okay, and then this value is the multiplication of these two ones exactly. Thank you for watching, and I hope you enjoyed it.